we are going to discuss one question from project quality management area. Question is, which of the following graph expresses the quality of the products in chronological order and is used for determining whether the manufacturing process is in a stable state within the limits of management. So the question asks, which of the following graph expresses the quality of products in chronological order and used for determining whether the manufacturing process is in a stable state within the limits or control of management. The question, the answer options are control chart, scatter graph, cause and effect diagram, Pareto chart. Let's first discuss about quality control techniques. There are 7 basic tools of quality that we have outlined here. These are stratification, Pareto chart, cause and effect diagram, histogram, scatter diagram, check sheet, control chart, and graph. Some expert divides the control chart and graph in 2 separate categories. On the other hand, some other experts combine them in one group. So sometimes we call it as 7 basic tools of quality, or sometimes some experts call it as 8 basic tools of quality. Let's discuss about these quality tools in detail. Let's discuss the individual techniques one by one. One technique is stratification. This technique involves sorting of the data into groups to pull out the main elements in each sample population. So there is no graph or diagrams for this sorting of data into groups. For example, one could sort the data into various category or stratums based on time, geography, workers, products, etc. And by sorting the data or dividing the data into various category or groups, the characteristics that exist between the data, that was previously not so clear can be identified. Another technique is Pareto chart. In this kind of chart, this chart shows the individual values in order of their sizes by bars. These are the bars for individual values. And also there is a line that represents the accumulated total So for example, in this Pareto chart, the largest value is item A. So this is shown first, then B, C, D, E, and the accumulated total of AB is shown here. Similarly, ABC is shown here, ABCD is shown here, and so on. And this kind of chart is used in one technique called ABC analysis, where we divide the inventory items in three level of priority category. A is the highest priority items, B is the normal priority items, and C is the low priority items. This Pareto chart is used. Another quality improvement technique is cause and effect diagram. In this diagram, we show the relationship between the characteristics and its effects along with the speculated primary factors. So it shows the relationship between the characteristics and its effects. Characteristics means here the product's performance and functions. And for each characteristics, there are some primary factors that can affect these characteristics. This kind of diagram looks like a fishbone kind of structure or form. So sometimes this diagram is also called fishbone diagram. Here we have shown one cause and effect diagram. There are four important characteristics shown here: communication, skills, transport, procedures that causes the incorrect deliveries. And for each characteristic, there are primary factors that affects these characteristics. For example, one characteristic is procedures. One factor is manual procedures, and another is automated procedures. Manual procedures are affected by consistency. Automated procedures are affected by reliability and correctness. In total, all these primary factors affecting these characteristics, and these characteristics incorrect deliveries in this case. So, by identifying the relationship between the outcome, that is this outcome, and the cause that led to the problem, that means these characteristics and their primary factors, one has effectively identified what needs to be improved on to improve the quality of the product. Another technique is histogram. In this technique, we basically shows the spread of the data by the size and shape of the bars on the graph. So the range of data in this histogram is divided into appropriate section, and within each section the data that fall within it is charted. If you look at the histogram in this example, we are showing the date range data in the x-axis, that is date range, that means date 1, date 2, 3, 4, and so on up to date 10. And we are showing or charting the frequency to provide or to show the frequency for each date range, individual date range, using a bar chart. So this kind of diagram is called histogram. For example, date range 1, there is no frequency. Date range 2, that means in this section there are little frequency values. for date range 6, there are the most frequency is in the date range 6 and so on. Another technique is called scatter diagram. In this diagram, we basically investigate the relationship between two essential factors. That means when one factor value changes, how the other factors changes in relation to that. So in the scatter diagram, we basically investigate the relationship between two essential factors. Normally, we plot the values of these factors, one value in the x-axis and another in the y-axis. In the event when x increases, y increases, we say this is as positive correlation. For example, if you look here in this graph, when x increases, then also y increase for most of the plotted values. That means the graph looks like this kind of line, or most of the plotted values falls near this line. So this kind of relation is called high positive correlation. On the other hand, if x increases, then y decreases. This is called the negative correlation between the two factors. In this case, most of the values falls near this line. But for this case, this is also representing negative correlation, but the plotted values are not so near like this graph. So though there is a relationship, negative correlationship between x and y factors, but the relationship is low negative correlation. In particular, in this case, there is no correlation between the x factor and y factors, so we call it no correlation. So if x increase, y increase, we say this is a positive correlation. But if x increase, y decreases, then we say it is a negative correlation. Sorry, it is said negative correlation. If there is no such relationship, we call it as no correlation. Another technique is check sheet. This is basically a pre-printed check questionnaire used during the inspection stage, and it contains the necessary items and the contents that need inspection. For example, we are showing one check sheet here. This check sheet basically investigating the telephone interruptions and what are the causes for the telephone interruptions in the weekdays. For example, reasons are wrong number, information request from boss, and the weekdays also listed here. And we are actually collecting or gathering the data for each reason in this example. Another quality improvement technique is called control chart, and this control chart enables one to see whether a process is stable. So this chart allows us to see whether a process is stable. in this kind of chart, there is one center line and two other lines on top and bottom of this center line represents the control limit line, that is upper control limit and lower control limit. For example, here this is the center line and this red line represents the upper control limit and this one represents the lower control limit. And then the characteristic value representing the state of the process would be plotted. Here we plot the characteristic value of the process. In case these values are within the upper control limit and lower control limit, and there is no tendency in the way how the dots aligned, one could consider the process as being stable state. That is, all the plotted values or most of the plotted values are false under this upper control limit and lower control limit, and there is no tendency or biasness of the values in any specific region, like this region or this region. Then we can say that the process is in stable state. On the other hand, if these plotted values are clustered in this region or in this region, that is in the upper control limit region or in the lower control limit region, then we can say that the production process is problematic. Another quality improvement techniques are plotting the graphs. There are many kind of graphs we can plot. For example, line graph like this, where we can see any shifts in the item or items and changes in time. Like here, this is the time and this is the number of people, and we are observing the number of people in a store in a given point of time, and we are plotting this using a line graph. Another way is bar chart. It compares the size of the value at a particular like the sales by year. We plotted one bar chart, and we can easily compare the sales figure using this bar chart. Other graphs are a pie chart that shows the percentage breakdown at a given point of time. Like there are many samples, and we show here the percentage breakdown of each kind of sample. Another is bar graph, and it shows the changes in time and percentage breakdown of each item. So these are the items, and we show these items percentage wise for like year 2012, year 2013, and so on. And we are showing that, okay, these items like this 10 item is changes positively like this way, but however this category item is decreased over time, and so on. Another technique is called radar chart. It is also known as spider chart or star chart. It shows the balance between the items and characteristics. In this particular case, the items are speed, efficiency, safety, comfort, and reliability. And the characteristics we are showing here is the ultra speed and super economy. Let's come back to the question again to find out the answer. Question says, which of the following graph expresses the quality of the products in chronological order and used for determining whether the manufacturing process is in a stable state within the limits of management? Option A says control chart, and if you remember the discussion about the control chart, we have seen that we plot the characteristic values of the manufacturing process and in a chronological order, and if the values are between the upper control limit and lower control limit, then we say that this manufacturing process is in a stable state. So for this question, the correct answer is control chart. Scatter graph is basically shows the relationship between two factors. For example, like if one factor increases, whether the other factor increases or decreases. So this is not the correct answer. Cause and effect diagram basically shows the possible causes for the given outcome. It tries to find out the reasons, and then based on this reason, quality improvement of the products can be planned. So this is also not the correct answer. Pareto chart is basically shows the individual items or values based on their sizes. Also, there is a line chart in the Pareto chart that shows the accumulated values of these individual items. So this is also not the correct answer.